So ultimately we get the PDF of the Gaussian random variable as 1 upon under root 2 pi sigma square e to the power minus x minus nu square upon 2 sigma square. And if in this formula we place the mean value equal to 0 and the value of sigma square, sigma equals to 1, then we'll get the formula in the simplified form. PDF of this Gaussian random will be minus infinity to infinity 1 upon under root 2 pi e to the power minus x square dx, that is equal to 1. So we know that on integration of any function which is a finite function or which is the function of random variable, let's say x, so the on integrating we get the value equal to 1. If some sort of curve like this curve is there and instead of this curve if some other shape of curve is there, then also according to this formula the value will come like area under the curve. We will find out the area under of the graph, whatever the graph is given we'll find out. Then we can see at last found that the value of or the area under the curve will come out as 1 only. So like now we need to find out what is the probability that the random variable assumes value x greater than 7. So for x greater than 7 we all know that for integration minus infinity to infinity is there, and since we need to find out the probability greater than 7 only, so minus infinity to 0 value will be neglected. So I have not written that portion, I have just directly written from 7 to infinity this particular formula 1 upon under root 2 pi square e to the power minus sigma square upon 2 sigma square upon 2 upon sigma square upon 2 sigma square. This one I have left out, sorry. That like for example, if as in the question if it was given that the variances we like if this coordinate is given as like 4,9, so 4 will always take the value of mu and 9 will assume the value of sigma square, that is 9 will take the value of sigma square is nothing but the variance. Okay, so under root 9 will get 3, so we'll place the value of sigma over here and then finally we'll get the value. So like if we need to find out the directly, if we do not have any some sort of calculator, then we can find out the value using the q function. The q function says whatever the random variable is assuming the value greater than that will be written over here like q is p of x greater than 7, so q of 7, whatever the random value variable assumes a value will be written over here. So minus nu upon sigma, this will be the formula of q function. So finally we get the value on solving this q1. We'll be given the table over here of q tables which will consist of different values. So while seeing the value from that table we'll easily get to know what will be the value of this q of 1. So likewise we need to find out the value of p of 0 less than x, which is p random variable x, probability that random variable x assumes value greater than 0 and less than 9. So likewise this one is a shortcut. Like whenever we are having the probabilities in the term of exponential, we need to find out this take this q function and then get the answer. Q of what is this, as it is greater than 0, so 0 minus mu upon sigma, like as we have done same like we have done in the previous one. So q of 0 minus 4 by 3 will be this. So similarly in this way q what is the probability that the random variable x assumes value greater than 9. So instead of writing minus and 9 to infinity directly value, we can use the q function and then get the value of it. Q of 9 minus 4 by 3, q of 5 by 3. Q of 5 value will be given to us in the examination hall. So from using that value we can easily solve the question. So like for example, if the probability that the random variable assumes very smaller values. So for that also, same formula, q formula will be there. Q of the value which assumes greater than this minus nu, that is sigma, that is the mean of the variable, upon q to the power minus 4. And similarly, like this, for example, and let's come to this. What is this? Like in some of the questions, if the random variable assumes a value greater than this and less than this, 10 to the power minus 4. Okay, so if we need to find out the value like this, like we have e2 by e1 is equals to p of e2 intersection e1 upon p of e1. So p of e2 intersection e1 will get this. It's greater than this. I think that somewhat this will be intersection. What will be this value? I have missed over here. So this is the formula. Using the Bayes theorem, we can calculate, like, what does the Bayes theorem say? Like, this is the Bayes theorem. You can even recall it very easily if you have learned before. I'm not going to the basic how this value is being come or the formula is being derived. So e2 intersection e1 will be p of like random variable x assumes value greater than 10 to the power minus 4, and this intersection values will always we will get in the when the we find out the common values between them upon p of x greater than 0. Okay, in the later sections I will tell how this value will be repeated over here. So p of x greater than x equal to 4, also same process will repeat like this. Okay, yeah, so the same thing is written over here. Gaussian random variable called the standard normal or the Gaussian random variable as nu is equals to 0 and sigma square equals to 1. You can easily see that how the previous questions have been done on the basis of this formula. Q minus qb is 0 to b fx dx minus is to b x square. Okay, where x is an increasing function and qx will be the decreasing function, because as the x increases, you can see that the slope is gradually decreasing. You can see as x is increasing, the slope is gradually decreasing, so we can say that x is an increasing function of q of x. Okay, yes. Now the same, how to find out the cumulative distribution function of the random variable. We all know that differentiation of the PDF differentiation of the CDF, we get the PDF. Like CDF is the integral form of we integrate the value up to x, like x equals to 1, then x equal to 2 and x equal to 3, where small x will always be greater than capital X. So it will, this according to this question, the probabilities at x equal to 1 to up to this particular x, let's say small x is 5. So probability that the function's random variables assume the probability of 1 to 5. So all the probabilities will be added and then we'll get the same is written over here, that x assumes value greater than minus infinity to infinity less than equal to, so minus infinity to x 1 upon root 2 pi sigma square e to the power minus x square. This is the Gaussian random variables value. Okay, x is a Gaussian random variable. Function is defined for the purpose of calculation. CDF qx equals to p of x equals to x greater than x to infinity e to the power minus x square. So overall, in general, CDF is non-decreasing function, we can see. So CDF function of the normal variable is described as like minus x minus infinity to x on upon under root 2 by sigma square e to the power minus x square. So we will get the value like this.